Our panel continues with experiences and overview. So in this part of the panel I'm going to cover, or at least I'm going to review the background, discuss the systems approach, talk about the decision and how it was arrived at, share some of the results and experiences with you, and then summarize the presentation. To provide some of the background, the Master of Software Engineering degree began as a joint program in 1995 between the University of Maryland at College Park and the University of Maryland at University College. There are several universities of Maryland, believe it or not. The University of Maryland at College Park is a traditional research university with full-time students. Most of the classes are given during the day. University of Maryland University College is a teaching university. Most of the classes are given at the evening. The first class in the software engineering program, MSWE 601, ran in the spring of 1996. Classes were supposed to be held at two local sites, one at the main College Park campus, the other one in one of the suburbs called Shady Grove. However, there have been difficulties since the inception of the degree, mainly based on the culture of the institutions and the scheduling of the classes. And finally, in 1998, the University of Maryland at College Park requested that the joint degree be terminated. The degree itself is a pretty conventional degree. It's based on courses. There are 4 core courses given at University of Maryland University College: MSWE 601, the Introduction; 603, Systems Engineering; 605, and 615. And then there are 4 courses given at University of Maryland of College Park. Students have to take 4 core courses at each institution. After they've completed the courses at each institution, they can take 3 electives. Based on managerial and technical topics, they're required to take 2 electives at one institution and 1 at the other. And then there's the capstone course, or at least the way it was in theory, that was a joint course given by both institutions, and that was MSWE 617, the Software Engineering Project class. So once College Park had decided to drop out of the degree, we were faced with a problem. What do we do with the students? Do we phase out the joint degree, which means we terminate the program and forget about software engineering, something that is becoming increasingly important in our culture? This gives us a problem in which each of the students has a different number of courses, and if we're going to run courses for a while and then we're going to have to scramble around and find substitutes that the students can take or give them individual studies, and the degree is going to be an orphan degree. On the other hand, if we start our own degree, we're going to require administrative and faculty resources. The advantage is minimum customization because we'll have classes that we'll run. But what about the quality of the degree? And we're going to need to attract students. Will the students come to a university college only degree? After all, it's College Park that is very highly ranked in their School of Computer Science and Engineering. So we applied systems engineering principles to solving the problem. We made the decision and then generated the analysis to justify what we had decided. Well, in terms of administrative and faculty resources, if we were going to phase out the degree or if we were going to continue it, in the short term, we're still teaching those classes. We're still administering the students. So those resources would be identical in both options. If we were going to run the degree on our own, we would have to replace the core courses that College Park ran. And we found that University College had similar courses in its other programs, so there was some overlap there. And we also found that most of the electives that College Park offered could be ignored, since when we looked at the history, we saw that students were only signing up for the database class, and again, we had a substitute. In fact, that substitute had been allowed by my predecessor as the software engineering program director. So recognizing that there was an overlap in some of the subjects covered by other classes in other degrees, we developed the Consolidation Model. What we would do would be to combine and reuse existing courses while we were updating our software development management track courses in our Master of Science in Computer Systems Management, CSMN. And also we had a project management course in our technology management program that could be substituted for the project management course in the software engineering program. And then, where there were gaps in the body of knowledge, we would have to create new courses, and this would fit in very nicely in the University of Maryland University College culture, because in the Computer Systems Management degree we already used courses from other departments. Now, there were some major advantages to the consolidation model. First of all, the cost of tuition to the students would be reduced because the UMUC only courses were cheaper than courses in the joint program for historical reasons. There would be minimum faculty impact. We're already teaching those classes, so we've got the faculty, and there's no need to find new faculty, at least for those courses. Most of the classes that we would reuse were already online or scheduled to go online via the University System of Maryland Web Initiative in Teaching. That meant, hey, we could put a degree online within 6 months by converting only the introductory course, and we found that we only had to add one new course. The disadvantages of the model was there would be impacts across other departments. For example, the project management course was moved out of our department into the TMAN course. So the model gave us a basic degree. We knew what we were going to teach, we knew what classes we knew what we had to develop. So we had to guarantee that to our students that the quality and the breadth and the depth of what we were going to teach was at least equivalent to other universities. So what do you do in this case? Well, you benchmark. So we went out on the web and we took a look at 19 universities, 15 in the United States, 1 in the United Kingdom, and 3 in Australia. Australians, I've noticed at this conference, have this a vision that they have to look to the United States to learn how to do things and to gain the knowledge. And you know something, that's not true. I've worked in systems and software engineering in the United States for many years, and I'm excited at what I've seen at this conference. I think that there are many things that Australia can teach the rest of the world. After all, when you think about it, their projects are characterized by massive cost overruns and schedule delays. Why do you want to learn how to do it wrong? And because of the web, you're not as far away as you think you really are. Coming back here to this program, software engineering is being taught differently by different universities. And in each program, we noticed that there was a ratio of core and electives that was different in most cases. And what was more, we found that the different universities taught software engineering in different ways. There's the functional differentiation of the body of knowledge, a course-based degree, Maryland University College, Carnegie Mellon, DePaul, Emory, Riddle, Kansas State, George Mason, and the others. And then there was a program that was pretty much customized. It was all electives. The advisor and the student defined the curriculum out of a set of body of knowledge, Oxford and Melbourne. And then there was a mathematical logic language theoretical approach, Brandeis, Griffith, Seattle, etc. So we decided that we would focus at least our benchmark on programs that were similar, namely the fundamental differentiation of body of knowledge. After doing the benchmarking, we found that we only had to make very slight modifications to our prototype curriculum. We found that nobody taught a course on software maintenance. And since in the systems and software lifecycle, systems spend 67% of their budget on the operations and maintenance phase, this is a hole in the curriculum in most universities. So we added the course on software maintenance that we already had in the CSMN degree to the core. We decided to add one additional elective on models and simulations that we don't have. We moved the information security course from a core to an elective because most people either taught it as an elective or didn't seem to be teaching it. We moved the software V&V course from elective to core because V&V testing and evaluation is an important topic. And we substituted the University College database class for the College Park database elective, and we deleted the remaining University of Maryland College Park electives because nobody was taking them anyhow. Now, we were faced with the issue of what about labs? if we at University College did not have a lab, and if we were going to put this program online, how do we overcome the lack of the labs? Well, if you look around at the state of the art, first of all, most of the people who are in this degree program are working in the information technology field, so we continued the requirement for 1 year's experience of working in information technology, because there's a whole culture in that business that we can't teach. The students have to come into the program knowing a modern computer language such as C++ and have the ability to program a little bit, and they're required to have some knowledge of discrete math, which is the mathematics of programming, so they can understand programming algorithms. And then we would give them the final project, MSWE 617, which is basically an exam. The students would experience the entire system and software development lifecycle in a team and take a project from conception through to implementation. So back last January, we put the analysis and recommendations to the Graduate Council of University of Maryland University College, and the Council decided to offer the UMUC only degree on a trial basis as of the summer of 1999, and to put the degree online starting with a full semester in 1999, and at the same time to do a sanity or milestone check on the degree in September 1999. Well, I'm proud to say that that sanity check was carried out a month ago, and the Graduate Council approved the continuance of the degree for another year. And this is a first at University College in that the degree will be checked every year to determine whether it's economic and feasible to run. And I like the idea of having a quality check on the degree at periodic intervals.
The focus of the Master of Software Engineering degree is applied rather than theoretical. The students take core courses, 3 electives out of a set of managerial or technical electives, and then complete the final project. It's built on our UMUC baseline of offerings and the use of adjunct instructors. The use of adjunct instructors in software engineering is an advantage because these people who are working out in the field bring the real world into the classroom, and so the students don't just get academic exercises. And it's really an extension of the old craftsman-apprentice model, where the instructor is the craftsman and the student is the apprentice. And in the IT world, where it changes rapidly, this is an advantage rather than a disadvantage. We also built the degree on a set of assumptions in that the students have access to computers where they are. The students don't have to come to the computers. Traditionally, in computer science degrees, the students have gone into the labs to use computers. But these days, with the power of the PC, the students can do everything at home other than the networking exercise, which they probably wouldn't do in the classroom anyhow.
So back at the decision point in January, the status was all existing or proposed classes were online except for 4. MSWE 601, the introductory class, which went online in the fall. MSWE 603, the systems engineering class, and we plan to put that online in the spring of 2000. MSWE 617, the project class, that's a problem because one of the major problems that we were facing in online teaching is showing the students how to collaborate in an online environment when the students are separated geographically from each other and cannot get together at mutually convenient times. For example, how does a student in Korea, California, Texas, Maryland, and Germany, how do they all work together as a team? And there are difficulties, and we have to face that and solve that problem by the spring of the year 2000. So what we plan to do in the spring of the year 2000 is to offer the class as a hybrid. The class would run in the classroom and the students could get together synchronously, but they would make their presentations in an asynchronous manner, as you're seeing here, and the design reviews would be held asynchronously. And hopefully by using that approach we could prototype the class and then test it out. There'll be no problems with distant students requiring to take that class in the spring because there won't be any. And then we also have to put together MSWE 635, which doesn't exist, and that's planned for the fall of the year 2000.
Our mission statement for the degree emphasizes producing software within the constraints of the cost and schedule estimates. MSWE 635 is designed with that mission in mind. The course would review project management, would review software lifecycle, and then discuss reasons for the prevailing paradigm of cost and schedule overruns. What it would then do is introduce in some industrial engineering concepts and identify how they might be applied to software engineering. This is based on a paper presented at PICMET by Dr. Brennan from Mercer University, who, by the way, is peer-reviewing CSMN 648 under the auspices of the Web Initiative in Teaching. So in order to implement the class in this way, the prerequisites required for it would be MSWE 603, the Systems and Software Lifecycle class, MSWE 645, the Requirements and Standard class, and TMAN 640, the Project Management class. And this class is scheduled for its first iteration in fall 2000 under the auspices of a syllabus that still has to be developed.
Now, the courses at UMUC teach how to specify, design, build, and test software, how to identify and make optimal use of resources, how to change and upgrade software in a controlled manner, and how to deliver a software project on schedule and within budget. And the metaphor I use for software engineering is musical. If you think about composing a symphony, and you have this symphony, and the musical score and the arrangement is changed after every performance, and after every few performances the instruments are phased out and replaced. That is developing a software project, software engineering. On the other hand, programming is compared to learning and play a musical instrument and then practicing on the instrument. So in the degree in software engineering, we don't teach programming. We assume that the students coming in have that knowledge and background. We teach them how to compose the symphony, how to choreograph it, how to arrange it, how to do software engineering.
The threads in a classroom, at least at the seminar level in the grad school, are shown here. There are lectures, presentations, which the instructor is lecturing knowledge to the students. Then there are group discussions in which the students discuss items pertaining to the text, and the discussion takes place student to student as well as instructor to student. Then there are student presentations in the class, and then there are individual communications in which the individual communicates with other individuals, student to student or student to instructor. I've talked about synchronous, asynchronous, traditional classrooms, and web-enhanced classrooms, and I'd just like to share a perspective how these relate to each other. The way I look at it is I look at a continuum. One end of the continuum is synchronous classes, and at the other end of the continuum is asynchronous classes. So you can see here that the traditional classroom is totally synchronous and lies at the synchronous end of the continuum. At the other end of the continuum, asynchronous, are the self-paced study kinds of classes, which can be on the web or correspondence courses. A little bit in from the synchronous end is the web-enhanced classroom, because while the classroom takes place in the real classroom, it's web-assisted, so there's a little bit of asynchronousness there. Similarly, at University of Maryland, University College Graduate School of Management and Technology, our online seminars are mostly asynchronous, but there is a degree of synchronousness in them. So what I've done is position them off the end of the asynchronous continuum. How far off the end? Well, that's really application dependent and personality dependent. But there is a broad range on the continuum for specific classes to be at. So now let's take a quick look at the sequence of events that we have to go through to move off the synchronous end of the continuum in the traditional classroom towards the web-enhanced classroom, and then further on towards the asynchronous classroom with the voice and PowerPoint lectures.
The first thing we do is start off with a regular classroom lecture using the chalkboard. The next thing we do is augment the classroom with a list server so that we can have discussions and pass information outside the classroom session during the rest of the week. Now, instead of using graphics on the chalkboard, I prepare my graphics ahead of time using PowerPoint as a presentation graphics tool.
And when I post the PowerPoint graphics on my website ahead of time, I've now got a web-enhanced classroom.
This was the baseline I started from, so the next thing I did was combine the sound and the graphics using real media so that I could transmit it over the internet. I now overlay my real media presentation on the WebTyco text-based baseline and end up with a virtual classroom, I hope. The traditional synchronous classroom is single-threaded. The lecture takes place, the instructor asks a question, the students answer the question, maybe one or two other questions are asked, the discussion takes place, and at the end of that mini discussion, the instructor summarizes the discussion, formally or informally, and then the lecture continues. So you can see this path here. It is basically a single thread. In the asynchronous classroom, the lecture threads are different. Here, it's multitasking, because when the instructor's in the middle of the lecture, the instructor can't stop and ask a question because the students aren't there. The students can listen to that lecture any time during the session. So the threads are shown here. There's the lecture, the question is asked, and the question has to be a type of question that can be asked independently of the continuation. So the lecture continues before the question is answered, before the discussion takes place, and before that area is summarized. So what happens is there's a branch, and each time a question is asked, there's another branch. So in the asynchronous lecture, you start ending up with several discussion threads going on simultaneously, asynchronously.
Now, in producing audio presentations, we are limited by two kinds of constraints. There's the equipment constraint, which means both the student and the instructor have to have the ability to create the presentations in their home office and use minimal, if any, extension of their current hardware or software.
Once I have the basic PowerPoint presentation created, there are two different approaches to use to create the sound files. The first approach is to create each of the sound files separately and then go back to the beginning of the presentation and link them in one at a time. A more effective way I found of doing this is to do the slides one at a time. So for each slide, I will put PowerPoint up in one window on the screen, and then I will capture the audio in GoldWave on the next window in the screen, and then I will insert the audio in the slide and set the audio parameters correctly, and then I've got the whole presentation. When I do that, it's ready and I can publish it to Real Media. Here you can see a sample set of options that the students have provided to get the instructor's lecture. They can view it through streaming audio in real time, where the presentation comes off the server, or they can download the audiovisual RM file to their computer using the FTP process and play it back. Or if they don't have sound capability, they can download the written text and read it. And some of the students love the sound capability in the distance class because it gives them the feel of actually being in the classrooms. And other students want the written capability because they like to take that and read it on the subway. So this delivery mechanism applies to both sets of students. Students can use which one they like. Other students will read it and listen to it so they don't miss anything. I've used asynchronous communications over the internet with a piece of software called Phone Free. It has two screen displays, as you can see here. And communicating with somebody is real easy. Click on their icon to communicate with them. Or if a call comes in, the handset pops up and click on the green area and you can talk. If the link is good and the computers are fast, it is just like a telephone conversation. Otherwise, there are delays, but then if you're used to radio links and you're used to saying over at the end of a conversation, over, and waiting for the reply, it works fine. And considering that there are no communication costs, it's good. I've used it in the summer of 1999 to communicate with a student in Korea.
The results. The program went online in May of 1999, and it is the fastest growing degree at University of Maryland University College. The enrollments are up 40% in 1999. I developed expertise in online instruction simply because I had to do it in order to bring the program online, and developed a web page resource that has many different lecturettes on asynchronous distance learning And you can go there and you can view some of these presentations in your own time. And there's a lot of information on how to put together courses, how to prepare voice and lectures. And that's http://worldwideweb.umc University of Maryland University College.edu/J Kasser. Go look at the asynchronous distance learning or the requirements workshop bullets. And the program is slowly returning to the master-apprentice model, where we are using adjunct professors who are out there in industry. They're fighting the fires, they're doing it, and they're giving the students the benefits of the experience, teaching them what works and what doesn't work, so the students just don't get these academic theories that may or may not work in practice. Found some innovations in the use of technology in order to make the resources that we have cope with the requirements that we needed to run the degree, and at the same time the students have produced some innovative products, and it has reduced the classroom preparation time considerably in preparing for courses.
On the topic of innovations in the use of technology, I put up a student frequently asked question page. I put up web presentations on how to do things using streaming audio. So you can learn how to put together a presentation like this, or how the web conference works, or any other presentations. And I don't want to insult Kim Kelly, but I saw Kim the other day and she told me that she'd watched my presentation on building the audio presentation and put one together. So if Kim can do it, anybody here can do it. We've used list service to web assist classes. We've set up an MSWE department email account. That's mswe@umUC.edu. That's part of the transition. And we're also using it to get inquiries. Kimberly is receiving that email, and we put that up on Thursday. She had her first question on Friday morning, and we've had 2 more since.
Actually, 2 more just came in this morning.
And we've provided instructor web pages so the instructors can put their presentation graphics on the web and the students can download them ahead of time.
And here's an example of the student presentations. You can scroll through the list of presentations. They can be sorted. And when you click on the title, you get to the next level on the website. This web display gives you an abstract of the presentations, how other students have rated it, and the options to view it, download it, or rate it.
And also in MSWE 617, the students developed the Farley file, which is a way for all the directors and other people to share information about the students using the local area network, and that software is available for anybody who wants to use it. Another achievement, not so visible, is the use of resources. When a class is run, the first time it runs, the preparation time is a lot longer than the second and third time it runs, because the first time it runs, we're actually building the class. The online class has 2 elements in it: the preparation, which is equal to the lecture time, and the dialogue or the interaction between the student and the instructor. The classroom class has 3 elements: the preparation time, the lecture time in the class or the classroom time, and the dialogue. Well, in the online class, as I said before, there is no lecture time, so the preparation time is the lecture time. First time CSMN 648 ran in the fall of 1998, the average preparation time was about 10 hours per session. The second time it ran, that dropped to about an hour and a half, and in the fall, so far, it's down to under 30 minutes. This allowed me to spend more time on dialogue with the students. In the fall of 98, there was an average of 3 hours spent in dialogue with the students. In the summer of 1999, there was an average of 6 hours spent on dialogue with the students, but remember, I was running 2 sections at that time, and right now I'm running about 2 hours a week of dialogue with the students, but the class is only in the second session. When I ran the class in the summer, I was doing 2 sections, and this is a major advantage of the online class situation. In a classroom, one instructor cannot teach the same class or 2 sections of the same class on the same night. Instructor just can't be in 2 rooms at the same time. And sometimes it's difficult to get an instructor to do 2 nights a week. In the online environment, the instructor can teach several classes simultaneously. The only time there's a pressure hit is when grading takes place. When you have to get 50 papers graded within 72 hours at the end of the semester, things were tough. I was glad I was able to use the problems with WebTyco as an excuse for getting my grades in late. But seriously, by producing a class online and using the model of CSMN 648 in which the lectures are done in voice, I was able to develop a technique where one instructor can run more than one section of the class. This is how we are able to keep the MSWE degree going with the few amount of resources that we have.
There are still some remaining problems. For example, the students. Actually, it's administrative in the students. I wouldn't like to infer that to a university the students are problems. We have two streams of students. They're the joint students in the joint program and students in the university college only program. And we're looking at students transferring either between the two streams from the joint degree to the university college only degree, and also students who are in other programs, computer systems management, want to transfer in to the Master of Software Engineering degree. We still have to complete putting the MSWE 617 and 635 classes online. Actually, we have to create MSWE 635, and we have the problem of finding quality qualified instructors. University College has decided that they want a very high rate of people with terminal degrees in their teaching staff, and it is difficult to find people with PhDs who know these technical subjects and, what's more, have the ability to teach it. Well, like any other project, how are we going to know whether it's a success or not? Well, here are the criteria for defining success in bringing the program online. First of all, the program continues to grow at least 20% at an annual basis. Secondly, and just as important, we actually graduate students. The joint program has graduated students for the first time this year, and the UMUC only program should graduate students for the first time maybe in 2000, but more probably in 2001. And the other criteria is the software engineering project class goes online as planned, and also we do get to develop MSWE 635 and run it. So in summary, I explained some of the overview and shared some of the experiences, discussed the background, talked about the systems approach, the decision, the results, the problems that are still remaining. Any questions? And for the rest of the time after questions, I'll show a couple of examples of actual learning over the internet.